Welcome to Spring LIB.
So in this reaction, you have aluminum being reduced and an unknown metal M being oxidized. And what we can do is look at, so for any redox reaction, E0 for the reaction is going to equal E0 oxidation. This is going to be for the M metal, plus E0 reduction. This is going to be for aluminum. So we can use table 18.1 to look up the standard reduction potential for aluminum. So that gives us that value. Now, E0 reaction, we're given delta G, and so from delta G, we can get E0 reaction. So we're all set there. And that gives us enough information to find the standard oxidation potential for the metal. And then if we look in table 18.1, we would just take the negative E0 oxidation. That will give us E0 reduction, which is what's going to be in the table. So that will allow us to identify the metal. So we start delta G equals negative NFE0, and we rearrange for E0. Now, we have to identify the number of moles of electrons that are transferred in this reaction. And if you look at the balanced equation, that's going to be 6. So E0, we have to convert delta G into joules first. Here's our 6 moles of electrons and Faraday's constant. That's going to be 0.710 volts. So now we just have to look up the reduction potential for aluminum 3+. That's negative 1.66 from the table. We know E0, we just calculated for the total reaction, is going to be negative 7.1. That means E0 oxidation for the metal is 2.37 volts. Excuse me. So E0 reduction is going to be negative 2.37. That's what we're going to need to look up in the table. One other thing to consider too is that the metal has a 2+ charge. And so it's interesting, when I looked in the table, there are 2 metals that have reduction potentials of negative 2.37, and then realized that the reduction is, the oxidation is the metal going from 0 to 2+. So that means we need to find the reduction potential that has the metal with a 2+ charge, and that's going to be magnesium. If you look at the table, it's Mg 2+ plus 2 electrons goes to Mg. E0 is positive 2.37, but again, in the that is negative 2.37. Even though we calculated a positive here, that was the oxidation potential, so we needed to look for negative 2.37 in the reduction potential table. Now, there is another metal given that has a 3+ charge, and that has an E0 of negative 2.37. But again, we know from the problem that the metal is going from 0 to 2+, so that tells us that the answer has to be magnesium.